Okay, so this video is about the first day of 6.1, which is operations on functions. Today's lesson is going to specifically talk about the addition, subtraction, multiplication, division of functions. F and G are functions, so if we have the symbols F plus G before the X in parentheses, it means we're going to add function F and function G together. Subtraction, multiplication, and division. So, ways to show that functions are being composed. Those ways, and then there's some other ways that we can do it as well, but for today, we're going to just talk about these ones. So the notes at the top will get filled out together on day 2 when we come back and talk about this and check these answers. So literally the examples we're going to do are these 4 here. So we're just going to do the plusing, the minusing, the subtraction, and everything else. So to start on this first one, so I'm going to do zoom out here just a bit. F plus G of X means I'm going to take X plus 5 plus X minus 4 and simplify that. So X plus X equals 2X. 5 plus a negative 4 is 1. Done. That's it. F minus G of X. Notice I'm putting the functions in parentheses because that subtraction does matter. So you have X plus 5 minus X minus 4 equals X minus X is no X, and 5 minus a minus 4 is 9. So my answer is 9. Multiplying F times G of X, you're going to take X plus 5 times X minus 4. You actually need to distribute this out. So, I really dislike drawing lines, but we're going to go first, second, third. Wow, my purple pen just like crapped out on me. And then last. Okay? So, X times X is X squared. 5 times X is, or X times negative 4 is negative 4X. 5X, negative 20. So this is going to equal, I'm going to do it in 2 steps for this one. After this, I kind of just don't if I don't have to. X squared minus 4X plus 5X minus 20. X squared plus X minus 20. Division. Division is super easy, yet so hard. So, function f goes on top. X plus 5 over x minus 4. You cannot divide by 0. So, you need to tell me what x cannot be. So, what value in the denominator would make this a true statement to be 0, and that's the value x cannot be. So, over here off to the side, I'm going to take x minus 4, set it equal to 0, and say x equals 4. If x equals 4 in this equation, either one, I will divide by the value of 0. 4 minus 4 is 0. So x cannot equal 4. This whole thing right here, the fraction plus what value x cannot be, is the whole answer. Okay? Excuse me, my nose is killing me. Alright, so jumping over to B. Going to do the same thing again. F plus G of X equals X squared plus 4 minus X. So, add those together. X squared minus X plus 4. F minus G of X equals X squared minus 4 minus X equals X squared minus a negative X plus X minus 4. Order doesn't matter, so if the negative 4 and the X were switched, or the plus 4 and the negative X were switched, that's fine. My brain, you cannot do that. Also, signs. Make sure you pay attention to your signs. F times G of X is equal to X squared times 4 minus X, which equals 4x squared minus x cubed, or x cubed negative, let's try that one again. Here. Or colon negative x cubed plus 4x squared. Either one's acceptable. Last but not least, division. F divided by g of x equals x squared divided by 4 minus x. X cannot equal 4. This whole thing's my answer. How did I get this value again? Once again, take your denominator. 4 minus x equals 0. Add x over, x equals 4. That's the value that x can't be. This, not part of your answer. My nails need done. Sorry. They're getting really... This is your whole answer for division. Alright, jump into C. On every single one of these, you have an x in the denominator, so you have to pay attention to that. X cannot be in the denominator. So, with that, adding f plus g of x equals 3x squared plus 5 over x equals 3x squared plus 5 over x. X cannot equal 0 because you can't divide by 0. So on every single answer, I gotta write that down. Next one, minus 3x squared minus 5 over x equals 3x squared minus 5 over x. X cannot equal 0. Next one, multiplication. F times g of x equals 3x squared, oh, not division, try that again, times 5 over x. Multiply this out, you get 15x squared over x. Even though it simplifies to 15x, x can still not equal 0 because in the original function, x could not be in the denominator, so x cannot equal 0. It's kind of weird, but whatever function parameters that still exist on the function before you simplified still have to hold true. So, division. Three x squared divided by 5 over x. X cannot equal 0. This should be simplified, so if I divide a fraction, this becomes 3x squared times x over 5, which goes to 3x cubed over 5, but x can still not equal 0 because in the original function of 5 divided by x, you could not pick the answer of 0. So when you take two functions and make a composition of them, doing operations with them, the parameters and the domain and range of each function still hold true. So usually you won't have something like this. You'll have something like A, B, and D. We haven't done D yet. But you got to remember that in certain problems, if your domain and range is restricted before you start, those parameters also hold true when you do other things. It will come up later on. So just pay attention to what values x cannot be before you start. Meaning, do not divide by zeros, please. F plus g of x equals x squared plus 7x plus 12 plus x minus 3. X squared, 7x, negative 3. So x squared plus 8x plus 9. F minus g of x equals x squared plus 7x plus 12 minus x minus 3. This equals x squared 7x minus x is 6x. 12 minus a minus 3 becomes plus 15. Times them. This is just like what we just did in chapter 4 and 5. Make sure you distribute x and a negative 3 to all parts. So with that, I apologize, my back is killing me right now. X squared times x is x cubed. 7x times x is 7x squared. 12 times x is 12x. Now, negative 3 times x squared is negative 3x squared. Negative 21x, and then negative 36. Combine those two. X cubed plus 4x squared minus 9x minus 36, and that's it. Last but not least, division. F divided by g of x equals x squared plus 7x plus 12 divided by x minus 3, and x cannot equal 3 because if I plug 3 into the denominator, 3 minus 3 is 0. So your homework is on the other page. So if you take your note packet and you flip it over, it says 8 through 15, do not do 36 and 380, and it's around page 389, I think is what the book said, or 399. I don't know page numbers in your book, and I just are really not friends. So this is the lesson for Monday. Day 2 will involve everything that is on this page. It's not really hard, but it kind of gets a little confusing because you're going to have to do a lot of that plugging a function into another function. So try your best. Replay the video. Once again, the assignment is on day 1 here. Your lesson are these 4. Okay? Good luck. See you on Friday.